our timers are on. If we have them, I'm going to set a timer and we'll do as much as we can in that timer. Otherwise, math lab. And then after that, we're going to 8-2, and we are only spending 1 day on 8-2 matrix operations. Operations like addition, subtraction, multiplication, not division, thank goodness. But, you want to divide matrices? I don't think you want to divide matrices. Wait, 8.1 questions, do we have them, yes or no?
Just 17. Yeah.
Just 17?
16.
16?
The example in the book was even, so we can't really check it, and no other question had a similar format as
Like 17 and 16?
Like 17.
Like 17, okay. So I'm going to go ahead and get that ready if you guys don't mind. I'm also going to set a timer so that we can have that. I have the Jamboard up, and I think I have, I almost have it. Okay, first of all, what was weird when you guys went to go put this one in your calculator? I mean, either you have a question or you already been there, done that. So let's talk about it. What was weird when you went to go put it in?
4 rows, but only 3 variables.
Yeah, these RREF ones worked out real good if I had a square. If I had a square coefficient matrix. Joy and Paul, now it's time to stop talking. If I had a square coefficient matrix. What's wrong with the order of the coefficients? I have how many equations?
4.
And how many variables? Okay, so that's not gorgeous. Because then that means I technically have a non-square system, which is weird because I know it looks square here, but it's not in the coefficients, right? So when you go to take this and when you go to do RREF, remind me real fast, how do I do that? You guys go down or up either way, right? How do I get the name? Yeah. And then I got it and I hit enter and it's like, bleh. What's weird?
They had another column.
Yeah. So when they went to go do it, did they have my, right? Did they have my 3 variables? Yes. Do they have my 4 rows? Yes. But then what's going on there? But what ended up happening, guys? 1x equals what? 1y equals? 1z equals? So who's that dude? Something. Something, right? I have a little bit of an issue. So as you guys were looking at number 16, if I come back over here, yeah, something was off because I didn't have a W, right? And so since I didn't have a W, the idea is if I wanted to make this square, technically what I would have needed to have done, that was not the right place. To use RREF, I did need more. Wait a minute, was that my A? Hold on. Did it not save what I just had it typed in? Oh, why did I put it down there? Oh, that was it. Okay, sorry, I thought I put it in A. I didn't know I put it in C. Hold on, that's not even right. Because I did it to the entirely wrong matrix. I was supposed to do RREF, so I guess I put it in C for whatever reason. So let me go get C. Okay, that's way better. I was like, no, that does not make sense. Never mind. This is way better. Thank you.
That's what I got.
Yeah, I was like, that doesn't even... We got it. I was doing the wrong matrix. So as we're looking at that, guys, I have my 1x, I have a step with y and z, but what don't I have in that 3rd row? Yeah. I don't have z by itself. So therefore, if I don't have z by itself, what do I let z equal?
A.
And so then we go ahead and work our way back. So you guys should have then from this gone ahead and seen that you were supposed to use z equals a. And solve from there. So if I was to come back over here real fast, we would go there. We would take this and we would make a nice little system of equations. This is one to where you need to use your human faculties to finish this problem off. You have 1x is equal to -5. You have 1y plus 4 times z equals 7. So when z equals a, we can go ahead and plug into that dude to go right there. And so then we can allow this to be y equals 7 minus 4a. Put those 3 pieces together, ba-dum, and I think you guys are good to go. Any more questions on number 16? Okay, so the calculator can only go so far if it's an infinite number of solutions. Does that make sense? It's looking for the identity matrix and the nice little pretty answers over here. If it's not nice and pretty, it gets you as far as it can. What form would this be? What form would this be? Is it REF or RREF?
REF. Yes.
It is REF because that's the more general one. So it's definitely REF because it has ones and it has zeros below.
It says it's RREF, but
It says it's RREF. How can it possibly be RREF if there aren't zeros above? Ryan?
Because there's like, it's not unique. Like the answers aren't unique, so it can be completely different things. So that's why they have to let C equal A.
I see what you're saying. I'm not sure that's the reason why. This is the guy that doesn't ever have to be unique. There are lots of different answers for him because you can arrange or change some of the stuff above. This one is supposed to be unique because it's looking for the solution, and the solution it's supposed to be getting the identity matrix, which is only one matrix, and then getting the solutions. But there actually is a reason why this passes RREF. It does have something to do with Z equaling A. It does have something to do with there not being just one solution. Ryan, what do you think?
Because all reduced REF means is that you can get down to its most simplest reduced form that could possibly be. That's what this is.
And I think both of you guys are kind of skirting around what technically lets it be RREF. It gets it down to as simple as it could be. And as simple as it could be is the first column has a 1 and what? The first column has a 1 at the very top, and what's below?
0.
The second column has a
1.
1 that's staggered, right, in the second row, second column. And what else does it have above and below?
0.
The third row should have a
1.
And since it doesn't, there's nothing else to do for RREF. RREF technically doesn't say the 1 and then the 1 and then the 1 and then. It actually is the 1 and then, the 1 and then the 1. It's not there. We have our form. I'm going to go ahead and go over to this one real fast because I want you guys to look at it. It is a system of equations. There are multiple conditions that need to be done. There are multiple conditions that need to be done. The question I want you to ask yourselves is, what constants are in the problem? What totals are in the problem? Okay, thank you. All right, cool kids. As you read, the city zoo borrowing $2 million at a simple interest rate to construct a breeding facility. Guess what? No bank would loan them all $2 million. Have you heard people with multiple credit card debts? Why? Or needing to put a single purchase on multiple credit cards? Why? Why would anybody ever use multiple cards for a single purchase?
There's different money on them.
Like that their credit score doesn't drop drastically.
Oh.
They have to pay back more.
You're going deep. I was thinking more like a necessity, like they need to use multiple credit cards. Why would you ever need to use multiple credit cards for a single payment? Now, do you ever want to be near a credit card limit? Never. Take personal finance. Oh my goodness. Debt. But coming back, spending above your means. Some things are life, you cannot avoid them. Most things you can't avoid. Coming back. But yes, there's a credit limit. So what if you want to make a purchase and you're like, but I have this card and this, you've seen in the movies if nothing else, but I mean, this is real life. You've seen people use multiple credit cards. How about this one? How about that one, right? It's because they're at the limit on multiple cards. Why do you think the zoo borrowed $2 million from 3 different accounts? It must have, no bank wanted to loan them $2 million. Because why else would they take out money at a higher interest rate, right? So they would have maxed this guy out. Why? Because they're only paying 9%. But it doesn't cover the whole thing. They're trying to do this breeding facility. Somewhere in their financials, they're like, we can do this, okay. So they're borrowing as much as they can here, and then what? As much as they would let them there, and then what? Well, let's take out as much as they'll let us, right? And then what? Okay, fine, as much as they'll let us. They're just trying to cover their loan, or cover the cost of whatever they want to do. Anyway, you might have been like, what's going on here? So, taking out $2 million, having to borrow from 3 different banks, or at least 3 different loans. And then they say to use a system of linear equation to determine how much was borrowed if their first annual interest total for like the entire year was $206,000. Whew. Wow. Anyway, coming back. And they also tell us the amount borrowed at 9% was twice the amount borrowed at 13%. If we're trying to make a system of equations, I was telling you guys, look for totals. Let's look for this side, and then we'll figure out the other side. Someone tell me a total something.
$2 billion.
Okay, so one total is they borrowed $2 million. What's another total? We know about their interest rate. Those are the only 2 totals that we know. $2 million is how much was taken out. $206,000 is what the interest is. Does it make sense for this when I start writing something like this?
Yes.
Right? 9%, now hold on, in math when we say 9% of something, what do we do? If you're trying to take 9% of something, multiply, and I don't have that something, so I'm going to make it a, does that make sense? So however much money was in this account, 9% of that is however much of the interest came from this guy, right? And then what? And then? And then we just figured out that they took out this much money from there, and this much money from there, and this much money from there, or the loan amount was, the loan amount was, the loan amount was. So what happens when I add all the loan amounts? Didn't they say they borrowed $2 million? Right? And so what's the final clue? I have 3 unknowns. I really want 3 equations. Anybody have another relationship that's in here somewhere?
9% was twice the amount borrowed at 13%.
So something was twice something else. Is it talking about the 0.09 or is it talking about something else?
13.
Yeah, it's talking about the 9% and the 13%, but am I putting 0.09? Is it talking about the interest? Equals 0. How do we get that? Hold on, wait. I just want to translate the statement. We're just translating the statement. So what stands for, what represents the amount borrowed at 9%? Good. This is what I took out of this or for this account, right? This is the loan that was 9%. The X is how much money is in that account, or was from that loan, I should say. And so what am I going to put here? But I don't like how that's oriented. So yeah, someone was trying to tell me get it equal to 0, but we needed the statement first. So I know the statement is x equals 2z, but I want all my x's, y's, and z's on this side. So what am I going to do if I'm taking that hint and rearranging it? Got him. X minus 2z is equal to 0. Guys, this is a word problem. Go throw that into your calculator. You know what to do. RREF, and you will know X, you will know Y, you will know Z. I'm going to put up on the timer. Those of you guys that need it, use it. Those of you guys that don't, take a quick mental break before we go to section 8.2. Those of you guys that need it, do it. Those of you guys that don't, quick mental break and or any extra questions. Yeah, I would say. So we were looking at the problem.
change something.
Yeah, you want to add
Yes.
that to something. So how could I get a negative? I see the negative stuff.
I did it differently. Because I'm not in it. But it is the same thing as this.
So that the system was looking.
Oh, you did not.
Okay, so
Alright, cool kids. What'd you get as your final answer? How much of the 9%? X is equal to? Cool. And then at the 10%? Cool. And then at the 13%? They took as much as they could. They didn't want to loan them very much. And oh well, it was the rest. That was the situation, right? Money. Was it worth it? I wouldn't want to be on their financial board. I'm assuming they're getting lots of visitors and they're thinking it will, I don't even know. I mean, breeding facility, everybody loves babies, so go team. All right, 8.1 done. 8.2,
Start.
let's go. You guys ready? It's meant to be all the way up until multiplication. It's meant to be all the way up until multiplication. Do you guys remember, was anybody listening, what I said this problem was having us work with, first of all? Yeah, no?
X and Y.
No. I mean,
Solving
yes.
the variable.
Setting
multiplication.
Setting equals. Before we do operations, we just have to think of equality. Now guys, this notation, is it going okay? Are we understanding it?
Yeah.
Are we remembering that the first one is the row and the second one is the column? Why did I make it NM? Sorry. Our notes have it M and then N, right? I think. Right? Wrong? M then N or N then M? Yeah, I think I did alphabetical. Okay. Let's see what else. So first of all, we could just talk about, like, this is just equality again. Like, in order for two matrices to be equal, they do need to be the same order, so they have to be the same size, and they have to have the same entries. So equality, first of all, was pretty nice and pretty easy, right, guys? Because what needs to be equal to what? Yeah, it had to be equal to the corresponding dude over there. And then this guy has to be equal to that guy. And then this guy has to be equal to that guy. Are we not scared of this because we know basic algebra? Right?
Yes.
5 is equal to 2x plus 1. Or some of you can just think about 2 times what? Plus 1. But I'd rather just do 5 minus 1 is 4 divided by 2 is... Now what would happen if this got 2 and this did not?
No solution.
It would be no solution because I can't have a single variable being two different things, right? Okay, how about the last one? So we know that x is equal to 2. That just confirms it. And if it wasn't, then it's impossible. What'd you guys get for y? Cool. So my final solution, if I'm writing it as an ordered pair, could just be 2 and 3. Cool. But we're not like finding a intersection or anything weird like that. Alright, okay, so that was fun. All computers put away. All notes should be out. All computers put away. We're in a new section. Farron, all computers put away. Joy, all computers put away. Jackson, Joey, Brendan.
That's all we have to do.
No, my notes open. I had people just like jamming out and not taking any notes. I had people only doing homework and not even paying attention. Sorry. All for one, one for all, if we can't handle it. Here we go. Ryan, go ahead.
Is that like are we done after that?
Yeah. It's just practicing equality. Okay, so what if we were supposed to be doing matrix addition? I know it's gonna go fast, but we have to get up to multiplication, and I need everyone to be tracking so that I don't have to be worried about what's going on out here. So, if number 1 is what it is, question, what is number 2? Number 1 is what it is, which isn't that exciting. I now can say that I have an additive identity. Here's an example of what an additive identity would look like for a matrix. 0 is an additive identity for a number. A 0 matrix is an additive identity for a matrix, as long as it is of the same what?
Corresponding entries.
Same.
That's not what you meant to say, I don't think. Because the 0 matrix won't be the same, but it will make them be the same. What needs to be the same? I heard it over here.
Size on the side.
Dimensions, aka the same. What's the snazzy word for matrices?
And times
Same size, same dimension, same order. So cool. What's going to happen when you add number 2?
Nothing
Thank you.
possible.
I tricked a couple of you into saying something. Why is it impossible? What'd you just tell me?
They're not the same size.
The additive identity has to be the same size so that it is legal to add. I can't add if they're not of the same size. Don't try making up what goes with what. If they're not the same size, I cannot add. Does that mean I also cannot subtract? And if so, why? Does that also mean I can't subtract? And if so, why? Ryan.
Because in general, they always, like, in order to either add or subtract, they kind of need to be like the same order. Like, it's trying to like subtract 2 fractions without having the same denominators.
But that wouldn't be impossible. That would just be messy without a common denominator.
Or yeah.
You know what I mean?
Well, can you subtract because it's inside of it? Or are you saying?
Say it one more time.
Can you subtract because those has the same like spot, like 1 1?
Like A11, 12. Why would the fact that addition is illegal also say that for this problem subtraction is
Because
illegal?
when you subtract, you have to distribute the negatives, so it actually just becomes the first one plus all of them, but they're negative, so it's just the same thing as addition, but
You guys hear Joey and Brendan's idea? Subtraction is just adding the
opposite.
opposite, is what we would say. Subtraction is adding the opposite, just like division is actually multiplying the what? Reciprocal. So division is multiplication, subtraction is addition. So yeah, addition, subtraction, they're gonna work along the same rules, right? So what if I was to say, ready, set, get it all right, go. Let's go. Have fun, I'm gonna pause the recording. People who are watching this can pause as well and see if you can get them.
Yeah.
I'd say about a third of the class is done with all 4, so I'm picking up and just kind of going slow and steady. Those of you guys on the video can just check in and see if you're getting it with me.
-2 would be -3 minus 6.
I just realized I didn't.
Yeah.
I've done
You better not do this in my head. Less speed and more are you feeling? You need to write.
Wait, what? For that long? I didn't see it moving.
Check him. Check me.
That's what I
Make
got.
sure.
Also what I got.
I I make mistakes too.
Oh, frick.
Also what I got.
I did not get me. My B was wrong. Okay.
Just multiply the negative.
Misty, is it fine for these if like we kind of do the work?
For people online and or for people checking their work, I'm just showing stuff.
Negative 1 minus.
But I would definitely, there should be some.
No, it's negative 1 minus negative 1. No, it's
Okay, so it's 1.
negative
No.
1 plus 1.
It's not plus 1 though.
What are you talking about? What's your
B!
Dude, it's negative 1 plus 1.
Okay. It was
Oh,
minus
okay, I
and
see
negative.
it. I see it. Okay, I'm sorry.
Yeah,
It
so
was
then you wake up the same
minus
day.
and, okay.
Yeah, because it's like 1 minus. Okay.
I got you.
Yeah.
How many did you get right?
All of them.
All of them, thumbs up?
First try.
So what have you practiced? What operations, guys? What have you practiced? What operations? Addition, subtraction, adding the opposite. Multiplication by a constant. Is that cool? Multiplication by a scalar, by a constant. We can still use scalar because it's dimensionless because there is no order. It's just a 1 by 1. Boring. Don't have to think about it as a matrix thing, or yeah, we can think about it as just a coefficient. So we did addition, we did subtraction, we did multiplication by a coefficient and putting it all together. Are we good?
Yeah.
So what else is there?
Multiplication.
But we did that.
Oh yeah.
Division. Well, okay, we could. Oh, could we do division? What could I have included as a part E that would show division?
1/3.
Oh, snazzy, you're already reading my brain. I could show the division, which would just be 1/3 A, right?
That'd be rough.
What would I do?
That'd be rough.
Well, it wouldn't be great, but I could do it.
Over 3.
Because it'd be 1 over 3,
Negative 1.
negative 1 over 3,
2 over 3.
2 over 3, negative 1. Do you guys know there's another way that I could write this? I could just write it like this. But then you would just think that's cheating, huh?
No. That's just a,
That's big.
that's just a
Well, I'm just factoring. Oh, I could have just done that to begin with. Anyway. Okay, but what haven't we done? What haven't we done?
Oh, using this to like solve for there.
Oh, A times B. And we haven't used it to solve. True. A times B? Okay, that gets interesting. Oh, wait. Sorry. I showed you something too soon. Can you guys show me what this would be if we factored out a scalar?
Oh, I think I know what this is. Oh.
So technically we could multiply by a coefficient or we could factor by a coefficient. So, I mean, there is that one extra skill. Factoring would have us do what? What could we pull out?
2. 1 over 2.
1 over 2. Bring out the division by 2, which is 1 over 2. And what would I get?
1.
2.
Negative
No,
3.
1. 5, 1.
5.
No.
Wait. I want you to do one more. You ready?
You're struggling.
I had 1 in my head.
Struggle.
I just said something else.
It's okay. We're all allowed to have struggle days. We're
Compared to 8.1, this is.
Make sure if you dish it that you can take it. All right, here we go. B. Question. What if I was to have something like this, though?
Make them all a
Common denominator.
Oh, that's what you would have to do?
Well,
What's my common denominator?
my brain just froze as I was speaking.
What's my common? Oh, Wyatt's got it. Wait, what do you got?
I don't have it.
Oh, just kidding. He was thinking. Who has it? Common denominator.
Okay. Oh, 20 does not work. 30 does not
Oh, my
work.
brain
Oh,
is not going like
30. Oh, no.
40 does not work. 50 does not work. 60.
90.
Yes!
60.
So, if I was to change this to 60ths, question, what would I get? P.S.
I'm just like crying, bro.
Oh, wait, 15. Oh, yeah.
So I can have 15 60ths, right? So I can multiply by 15 over 15. What else? 12 and 12? Cool. So what's this one going to become?
Negative 36 over 6.
How about this guy?
20. 40 over 6.
Yeah, so
Yes.
Woo! And then what can I pull out?
1 over 6.
Because we're practicing factoring out and making nasty matrices easier. Question. Could your calculator make it look nice?
I hope so.
I mean, we could put it in our matrix, right? And then we could go throw it in our edit. It'd be what size? What's the order? 2 by 2. How do I put fractions in my calculator? Oh, alpha y equals. Let's see. Can we do fraction? Ooh, look at that. That's nice. Then what? Can we also just do division bars? Oh. I don't know if I like that. So we could do some more alpha y equals. We could do 2 divided by 3.
Chris, did you just press on edit to
It's
get
like
there?
2 divided.
I know, I did it wrong. Yeah, remember you have to go to edit, and then we have to just make it a different size, unless we want to make it something different. What do I have? Oh, 2 divided by 3. Oh, and I was trying to do alpha y equals, and I didn't do it great. There we go, there we go, there we go, and got it. Which is negative 0.6.
Yeah.
So what if, so what do we do to get this again?
Second x to the negative 1.
Yeah, but what would cause the calculator to get this for us? To do all the common denominators for us?
RREF.
No, because our REF gets 1s and 0s. That's not going to help. REF gets 1s and 0. Think about the math. Think about the math. We're in a whole different section. The whole different section is matrix what? Starts with an O and ends with operations.
Operation.
What operation would let me get from here to here? We'd still have to figure out the 60. But once we figured out the 60, what could we have our calculator do? Reduce. I'm not sure there's a reduce function, but good idea. Oh, I wonder if our calculator will let us. Okay, no, not divide. So what else could we maybe try to do?
Oh, multiply by 1 over 6.
Okay, so if we multiply by 1 over 60, which is us pulling out 60, right? Let's see if it understands multiplication of matrices.
Yes. Woo! Oh, wait.
Oh, wait, and then
Did you see the
change it to fraction.
What if we do alpha 1?
Yeah. Fraction, or decimal to
I don't think
fraction.
that's gonna change me. Whoa.
Whoa.
Oh, I'm so smart.
Yes!
Look at me go.
No, wait, it's
We
different.
still don't have it.
What did it do?
It
Go
brought
to
it
the
back.
order.
What did it do?
It's the same thing.
No
Oh,
idea.
it reduced it. It reduced all the fractions, but it still didn't factor it out.
Yeah, it didn't factor it out.
Yeah.
No, it
We need to pull it away. We need to pull it out.
I say just do it by hand.
Copy it. 0.0.
Do it by hand. I know.
So much easier. You can take 5 minutes.
Use click home.
Why did you do that?
Wait, what?
Why did you do
Oh,
that?
because you did
Oh,
one
because it's
divided
technically like factored out like that.
No.
What?
I see what Brian's saying.
Right,
but
you're
you're
not
not
saying
saying-
No, because on our paper we write 60 and then the bracket and then we have the stuff inside. So if we just put like, oh no, never mind.
No, that's not right.
Never mind, not right.
You're not. Okay, go.
Are you okay?
I thought I cracked the code.
Okay, hold on. Actually, let me go ahead and do, what do we have first? We have alpha.
Wait, if you just have A and you
Not
times 60 by it, the denominator cancels out, so it's just still 15.
What if you put A over 60?
That makes sense.
You guys did notice that you can do fractions to decimals and decimals to fractions, right? Oh, bummer. That flips it the other way. What if I do math and then I just go to fractions? Okay, so we can make a matrix do stuff like go to fractions, which is cool. The question is, why did the 60 work?
Because when you distribute 60 to each variable, the denominator cancels out.
Because math.
It doesn't.
Because 16 times 15 over 60 is just 15.
If I wanted to pull out the 1 over 60, check it. Snazzy mathing coming. Begging for attention, but not for me, for you to see the math. You ready? What did we know that all of these needed? A common denominator. And we figured out that common denominator was?
60.
60. There you go. So check it. If I wanted to pull out the 1 over 60, why didn't division work? Can I just randomly put a 1 over 60 and have it stay balanced? No. But I can multiply by 1 creatively. And multiplying by 1 creatively says, if you want that, what do I need to do to the whole inside? What's 60 over 60?
1.
I can get this if I do this. Multiplying by 60 will allow me to know what would be left when I pull out the 1 over 60. It's all about math and keeping the balance. And if I want to pull out the 1 over 60, I have to multiply by 60 to keep it all nice and neat and even. So multiplying by 60 lets me know what's left when I divide by. Okay, fun math. Let's go back. I'm not sure if these are necessarily like something that we need to take a lot of time on. Let's come over to this guy. There are some properties. It's in the book. If there are any questions that bring it up, you can go check it out. I mean, it'd be great if this was a linear algebra class. We should probably go in because the entire semester would be matrices, but like matrices and then applied as a foundational skill for much higher things. But for our purposes, it's like one chapter. Let's skip the properties and let's go straight to what Brendan said earlier. What if we have A times B? And this is where you want to tune in, believe me. This is where you want to tune in. Because guys, let me tell you right now, this is totally legal to multiply. Totally legal to multiply. But in your heads, you should be saying, but they're not the same order. But that's not what needs to be true for matrices. Matrices don't need the same order. The only thing that needs to be equal in matrices is right here. It's not the whole thing that has to be equal. It's the insides. Meaning, I need the number of columns of the first to equal the number of rows of the second. The question is why? And it might not make sense unless it might not make sense unless I show you something. You guys remember, I mentioned a way back. A word problem a coming, and a word problem a coming with those dairy marts and the milk that they sell and trying to figure out exactly what they sell, when they sell, and organizing it in like a big old grid, aka matrix. I'm going to go ahead and write it in a little bit more normal of a way. But what if I was to say something like, okay, they sell skim, they sell 2%, they sell whole.
2% milk.
Chocolate milk is in its own special category like it should be. Okay, so
It's on a different
we have
tier.
skim, we have whole, as are the non-dairy milks. Skim, 2% and whole. Cool? We're not doing coffee shops, we're not going to half and half. Or heavy whipping cream. But just skim, 2% and whole. Okay? And then I mentioned about how this could be talking about something like, well, okay, I could put Friday, but let's just say like not business weekend, but normal weekend, which is Saturday and Sunday. And then what if, they're, okay, cool. So this is how many, which, okay, obviously they're negative numbers, so this isn't indicative of this word problem that's coming, but it's still the idea. If we were to have the rows be the different types of milks, the columns be the days on which they are sold, if they're trying to figure out how much money they make from said milk, then we could go ahead and bring in something else like, what could we bring in? We could have this be Saturday, this be Sunday. What could we label the other ones as? Profit. You do something like, okay, you have to buy it to sell it, so it's like how much you make and then how much you spend. It could be something like that. But what do you notice about the columns of the first and the rows of the second? What do you notice about the columns of the first and the rows of the second? They are the same label. Does that make sense? So the idea of matrix multiplication, which you're about to see as to how we multiply, is that if you're ever organizing data in matrices, you would, in order to multiply, you would organize it such that whatever these labels are would also be the same as these labels, and they might match up to some other. And it goes on from there. So it's like, oh, you want to break this down? Okay, let's break this down and talk about this. You want to break this down? Let's break this down and talk about this. Like it keeps on building sort of like that. The columns of what it was here, kind of like a dependent variable, it becomes an independent variable to relate it to something else. There's this whole like crossing down idea that happens. And that's exactly why the number of columns has to equal the number of rows, just because of how the operation works. Now, once again, the negative numbers represent how much milk you sold, not unless some little punk kid came in and like swiped it under his sweatshirt. But anyway, coming back. Let me erase those titles. I just wanted to show you, like in an example, we would make these match these, okay? And that kind of describes the math that we're about to do. I mean, that's just more of an application, but it kind of illustrates a little bit this whole, like, we need these guys to be equal because, check out the math. You guys ready? I'm going to actually, just to make life a little bit easier, do I have it on the next screen? Nope. I'm going to take a quick picture. And I'm going to spread it out, and then we're going to come back and see if this whole little idea makes sense about going across and down. Let me get the word example in. That'd be a little bit prettier. I want a whole slide. Ready, set, and let's figure out how to multiply by going across and then down. Do you guys remember the idea of a dot product? Okay. The idea of a dot product is, oh, sorry people online, I do not have the camera up today. But the idea of a dot product is that you had something with multiple dimensions. I'm erasing it in a second, just kind of look at it for a moment. We had something with multiple dimensions. Actually, we had two different things with multiple dimensions. So not described by one number, but described by two different numbers for some reason, like it needs dimensions to it, not just one, but multiple. We could make it a 3D, 4D, 5D, but not. And then this guy. And if we want to multiply multiple dimensions with multiple dimensions, do you remember what we did?
U1,
How did we do U dot? U1, V1 means what? I took this component times that component, I matched them up, and then what did I do? Remember how we had to multiply? Now, this, and then we put it all together. This was for vectors, and this was if we were multiplying horizontal times vertical. Matrices are more complicated, can we all agree?
Yeah.
There are more numbers, more levels, organized such that we have way more than just two, yeah? So I'm not just going to go across. I'm going to go across and down, but this process is going to be super, 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 super similar. You ready? I'm going to show all the math so you can see it. Define A times B. It helps when I highlight. I'm going to go across as I go down. What am I going to find? I'm going to find that -1 is going to be paired up with -3 when I do the first times the first, kind of like the U1 and the V1. And then I'm going to have the second be paired with the second. And then the first pair with the first, the second pair with the second, the row going with the column and matching up. Remember, Saturday, Sunday with Saturday, Sunday, I have to match them up. So, my first row with my first column, first row of the first with the first column of the second, is going to get my A11. My first row with my first column, like a dot product, is going to get my A11. A1 first row, A11 first column is going to get my first piece.
Okay.
So, I know it makes sense, but the question is, what is going to get my A12? First row, second column. So I'm still going to have a -1. I'm still going to have a 3. But instead of going cross down, it's going to go cross down and then cross over down. I'm going to remove this. And I'm going to do this. And I'm going to get -1 times what? 2. And 3 times what? 1. Now, pause for a second. Do you have this written on your page?
Yes.
Multiple years. It didn't really work with COVID because, of course, people were at home and not really doing what I was asking them to. A few were. But quite literally, if you were to put your fingers right here, I'm not kidding, if you were to put your fingers right here, first row, first column, wouldn't you be hitting -1 and -3, right? To start, first row, first column. And then what happens as I go across the row if I'm supposed to go down the column? 3 and -4. Do you see what I got?
Yeah.
So we're going to take this guy, +3. Take this guy, -12. And I do +3 plus -12. That's going to be my A11. I would go across and down. Then I would come back, reset, across and over down. -1, 2, 3, 1. Whoever I'm pointing at is who I'm multiplying by. We'll do that math in just a second. The question I have is, can you get A21 and A31?
Yes.
Can you get A22 and A32? Ready, set it up.
Okie dokie.
Artichoke. Ready, set it up. Have you guys heard the other one? All right. Can of Sprite.
Oh yeah.
Let's think of one for oh yeah. What's one for oh yeah?
Kool-Aid.
It doesn't rhyme.
It works.
Oh.
I'm going to slowly come behind. Especially for the people online. Guys that are in here are already working. I'm just going slow. 2, 1 would be second row, first column. The first, the first with the first, second with the second. Just take your time. You're not going to have to show this every single time once you get the habit, but take your time on this first one. crossover down would be the first of the column plus the second of the row with the second of the column. For those of you online, I'm taking this guy with this guy with this guy. I'm going across as I'm going down, the same way I went across and down with the first guy. Now I'm moving on to the third.
Can you kinda so since it's like the same format, you can do the same thing but just switch like the stuff from A.
You're switching whatever's switching. So you see
Yeah.
how the 1 is staying the same,
Yeah, like the whole time. Like,
but the 1, 2, 3 is changing? Go ahead,
Yeah.
the whole time.
the whole time, like kinda like on the left side, the -3 and the -4 are always there, and then like on the right side, like it's the 2 and 1.
So what Ryan is seeing is since I have the 1 right here, then the first column, is always going to be in that second spot. He's totally right. So maybe without even like thinking about matching it up for the last one, maybe we could look over here to this guy and say, okay, what's going to go in that first spot? 2. And what's going to go in the second spot? The 1, because that's my second column and that's what's staying the same in each of these. But then what's going to be going on as far as the rows?
It's gonna be 5 in this one, or for the bottom.
If I look here and here, these are the first row, so the first row is going to be here and here, right? The second row is going to be here and here and here and here. The third row is going to be, here and here, so that's going to be a 5. And here, that's going to be a 0. Yeah, Ryan, that's one way. I mean, ideally, you're not going to be doing all of this work every single time. Some people that will be helpful. Others, there is that whole idea of pointing at it with your fingers. There is a shortcut of coming. But yeah, you're exactly right. That is going to be a pattern that continues. But I have, what do I have? Cross down, cross over down. I need to go hit my second row. Nope, second column.
Now, is there a way to cheat it on the calculator?
That's the next.
For the part of the test that you can use the calculator on, yes. Ooh. But I just said the part of the test that you can use this test is a split, part calculator, part not calculator. So here we go, ready? I am going to show you how I would have done this without showing any work. Now, careful, I do that with matrices too, and I make mistakes sometimes with row echelon, reduced row echelon form, right? But still, remember how I said you could do the whole go over and go down thing at the same time? Go over like here's my finger, there's my finger, then go down, over, and then down. I'm going to do that by pointing. People online, I'm so sorry. But I'm going to point. And I want you guys, when I point, to multiply. So multiply, what do you get?
Next,
3.
3, and then multiply.
-12.
3 minus 12 is -9. Question, is that the same thing as -1 times -3 plus 3 times -4?
Correct.
Wait, can you do the point
Yeah,
thing
can you
again?
do
Yep.
that? Sorry.
Oh my.
We're looking for this guy. We're looking for this guy. I'm up here and I'm pointing, and as I'm pointing, I am pointing to the first row, first element, and the first column, first element. And as I point, you multiply. You ready?
Yes.
Multiply.
3. Negative 12.
3 plus -12, or 3 minus 12. So I do cross down, and then I do cross over down. Multiply.
-2.
-2 plus 3 is 1. Double check the math. Is 3 minus 12 -9, and
Yes.
is -2 plus 3 1? Yes. Now it's time for me to go to row what? Entry what?
4 times -3 is -12.
-12 plus 8. What's -12 plus 8?
-4.
Cross over down. What's 8 minus 2?
6.
Double check. Oh, was not supposed to be green. We should sue the color code.
Do you add them because it's kind of like the dot?
It's like the dot product. You can think of that in the sense that I have multiple dimensions I'm dealing with, trying to bring it all together. But yeah, negative 12 plus 8 is negative 4. 8 minus 2 is 6. That would make 6, and that would make negative 4. Got him! So you guys, do the bottom one. You already did it the long way. Do it the short way. I'm in what row?
3.
And I'm in what entry? The first one. You see it? I'm in the first one in the third row. Negative 15.
Plus 0.
Cross over down. 10. Dun 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 dun. Can a calculator do it? The answer is yes. The dilemma is, what would you have to do to have the calculator do it? Okay. What would you have to do for your calculator to do it? Ugh, come on, my ones that love to just not learn the math and only learn the calculator. What would you have to do to have your calculator do it? Alright, I have to put both of them in. Okay, I have to put this one in, and it's going to be a 3 by 2. And then I have to go through and put all of my, alright, it's a negative, and then it's a 1, and then it's a 3, and then it's a 4, and then it's a negative 2, and then it's a 5, and then it's a 0. That's A! Yay! Now what do I have to do? Okay. And I go and edit, and then I go make B, and then I have to make B whatever its size is, and it's a 2 by 2, and then I do a negative 3, and I do a 2, and I do a negative 4, and I do a 1. And then I get out.
You go second and click on that, and then time. Yeah.
Yay!
Okay. Ready, set, by hand, go.
Okay.
Showing as little or as much work as you think you need. Woo!
Oh, I was just looking at the board.
That's not the calculator, that's the by hand.
This is 1 1.
So on the recording, I'm going to go ahead and pause, because in here we're getting some work time in for you guys, depending on what is or isn't making sense. It might not help you as much. I'll pause to let them work. For those of you guys online, they were all writing their matrices frantically down, maybe not so frantically, and I said, have you even checked if it's legal yet? And they said, huh? And I said, well, remember, there's only certain times that I can multiply. I need the insides to be the same so that when I go across, I can match it up going down. If those don't match, it's not going to work out. So then they were like, oh, we better check. And so I went ahead and went across. And as I went across, I was going down. Guys, do those match?
Yes.
And most teachers would say you should probably write the order first. And what's going to happen if it matches? Good and go. If those two are the same, it's a good and go. If those two are different, it's an impossible and you stop. But here's something else to notice if I was to show this on the last one. This is a 3 by 2. And this is a 2 by 2. Because these matched, I was able to cross down and do my matrix multiplication. But did you guys notice what size my ending matrix is?
3 by 2.
Not only do you know whether or not you can, you also know what the answer should look like. So for this one, as you guys are solving, not only do you know that you can, but you also should know what your answer should look like. It should be a 3 by 2. It should be a 3 by 2. Ryan, go ahead.
On the last one, like, remember how it was like the dot product, so it would be like, or 2 multiplication things plus and another. Would we have like 2 plus signs now because there's 3?
Exactly. So like the first one I'm going to have, you guys cool if I just write the first one down to make sure we're okay?
Yeah.
When I point, you do what?
0 times 2.
Multiply, right?
0.
So what's 0 times 2?
0.
When I move, you put a plus. What's that going to be?
Minus.
When I move, you put a plus. What's that going to be?
So,
I have to bring together 3 columns of information.
thank you.
So it's going to be 3 plus negative 4 plus 2. Why? Because I'm multiplying it to 0. Sorry, not 3. 0, negative 4, 2. And as I do 0 with 2 to get 0, and then negative 1 with 4 to get negative 4, and 2 with 1 to get 2. I need to add all those together. It's kind of like a 3-dimensional vector that we didn't do. That's interesting. And then I go cross over down and cross over down. 0, 5, and 12.
Yeah, that's what I have.
Sorry, how do you get the 0, 5?
When I point, you multiply.
Oh, you go to the next. Okay. Yeah.
Remember? First row, first column. If you guys need for these first ones, get the hang of it by writing it down. First row, first column, first row, second column, right?
Oh, yeah.
Or what I say is cross down. So go across as you go down. Then cross over down. And you can keep on doing that for as many columns as you have. So cross down, cross over down,
Okay, I'm done.
cross over down as many times as you need to do to keep going. Let's see. Multiply, multiply, multiply. Wait a minute. Wait a minute.
3.
Multiply, multiply, multiply. Sorry, I do better when I point to it. If anybody isn't pointing, pointing makes it easier. Negative 6, 0, and 8. As long as you know your timetables, I guess. 12, negative 4, 8. Negative 7, 5, 42.
Oh, let me see. Would it be like 14, negative 12, 8?
Oh my goodness, I wrote the wrong number down. That's right.
Oh my goodness, I did it.
14 minus 8.
Oh my god. Wait, I need to see.
Plus 8. Oh, wait.
I don't know, double check. I wrote each of my steps.
Oh my goodness, that's what I got.
Oh.
And is it finally a 3 by 2 like I thought?
Let's go. That's what I got, baby.
Ask questions though, ask questions. Remember, I'm not showing quite as much work because I'm not showing the pairs in this one. I'm just doing the multiplication and going straight to what this is multiplied, but now we have 3 pieces. Let me pause, let me check. You okay?
This is
36, 46. Negative 2 and then 48 minus 2.
Oh, that's why.
You good? Because it was negative 7, 5, and 4. Is that okay?
Yes.
Okay, so what if I was to ask you to do something like this? Woo-hoo-hoo! Can we do exponents? Okay, let's just do squared. Just squared. Because squared is the same thing as multiplication, right? Isn't squared multiplication?
Distributing
Hold on, hold on, hold on. You're making up a rule that I haven't said is true, so let's check it and see if it is true. What is a squared the same thing as? A times A.
It's impossible.
What did, it's
Oh,
impossible.
because there's not enough rows for the columns.
Because if you put them next to each other, question, how does multiplication work? I go across as I go. I have a 1 by 3 with a 1 by 3. Can I cross down? And the answer is
Oh, so you
No.
did 3 by 1.
so therefore.
So you can never do it like against or unless it's a 3 by 2.
Oh, a 3 by 3 you could square. A 2 by 2 you could square. A 4 by 4 you could square. Hey, which ones can you square?
The
Anything
square.
that's
The
the
square
same
one.
as the square one.
The square one. Interesting. But anything that's not a square matrix, I can't square. But careful, would some of you guys have said 941? Yeah, you would have. I heard you say it. So here's the big idea, cool kids, of matrix multiplication, besides just how to do it. besides just how to do it. I said find AB. The question that I'm about to pose on that next slide is, what about remember how in the olden days, like, I don't know, with numbers, if you multiply A times B, it's the same thing as B times A. Like, 2 times 3 is?
3 times
3 times 2. But yes, it is 6. Good job, good job, good job. Coming back. But what would happen if I try to do B times A? I would have a 3 by 2 by a what? Is this good or bad? Because remember, we look at the insides and we say yes or no when it's a no. So will AB be BA?
No.
No. And even if BA is even possible, they are probably almost never going to be the same. But there is one one exception. Intersection I used in Algebra 1 today, sorry. Can you guys see anything? Does anything look weird up here? Can you usually like multiply these two and then that one, or multiply those ones and that one and it's still the same thing?
Yes.
Can you usually distribute multiplication?
Yes.
But didn't we just say multiplication is real weird when you do matrices? Can I draw your attention real fast to this second one? Do you know how you would usually just multiply it in whatever order you wanted? Do you realize that this is crucial for you to keep the same? If A is in the front, A needs to be in the front for matrices and multiplication. You can't just multiply it wherever you want. Or if something is at the end, do you guys notice about what's different? Is it CA, CB? No. With matrices, the order is important. So the big thing of this whole page, you don't have to necessarily memorize these, but the order in which you multiply is important because of this beginning fact. Matrix multiplication, we're working with multiple dimensions. Things get sticky, dicey, tricky. As they get sticky, dicey, tricky, we just have to be careful that what we assumed we could do before because the properties allowed us to, we can't do now. We have to make sure multiplying at the beginning, A is at the beginning of those multiplications, multiplying at the end, that matrix is at the end. I can't like have C at the end, then C at the beginning, or A at the beginning, and then A at the end. It would not be the same. It would probably be illegal or impossible. Otherwise, this is one that just so many people mess up all the time. Like all the time. Has anybody ever seen something in the front and like wanted to take it to both before?
Yes.
Just in general? You're like, take the C to everybody. And yes, we do use what's called distributive, but only when we have a what in between.
Plus or minus.
Only plus or minuses. Plus or minuses allow us to distribute. What does not call for distribution?
Multiplication.
Yeah, no. Or division. So if I have a single constant, guys, I need just a single constant. So I could take it into one matrix and then multiply, or I could take it into the other matrix and then multiply. But if I have a constant, it is not going to both, or else you are bringing in a C squared, and that's illegal. So be careful. Only distribute across plus or minus. Don't distribute across multiplication. I know this looks funny, but it just means 1C times A times B. Not CC, not C squared, not C for everybody. 1C, either there or there. Okay, to end off today, I said that there was almost, never a time where I can flip the multiplication, but what do you see literally on the screen right now? An A times an I and an I times an A, and what's true about the A times the I and the I times the A? They both equal A. If you guys don't want to show the multiplication, you don't have to, but you do need to write down identity matrix allows this to be true, only with the identity matrix. Can I say? A, I, and I, A. Ryan's packing up because he's leaving early for an event. Everybody else, though, is staying put, so don't pack up. But do you guys want to do some multiplication with me? You ready? As long as you talk it through with me, I'm not going to make you write it. We're going to make sure that we understand why this is true. And this is also the reason why the identity matrix is so stinking special and useful. Wherever he comes. Besides the fact that he shows up in RREF. Ready? What I point to, you multiply. Ready, set, go.
3,
3,
0, 0.
Oh, hi. Stays the same.
Yes.
Cross over down.
0, -2, 0. Stays the same.
You see it? This is the only orientation that would allow multiplication to stay the same, hence why it's called the identity matrix.
0, 0, 5.
If you understand multiplication, it makes sense. If you don't understand multiplication, you're like, What do I do for the second row?
0. Oh wait, no, sorry, 1.
Second row, first column, right?
1,
0,
0, 0.
0. 0, 0, 0. 0, 0, 4.
Do you see it? It's happening. Because 4 times 1.
It's staying the exact same.
So 0, 0, 4. For the third row, what do I do?
-1.
0. Or sorry, -1.
0,
0, -1, 0.
Oh, careful.
0, 2.
0,
2,
2.
0, 0, -1.
Oh, whoa, sorry. 0, 0.
-3.
So it really works both ways? I'll check it. What happens if we go here? Then I put a negative? Thank you. What happens?
Oh, 3.
0, 0.
Cross over down.
2, 0, 0. 5, 0, 0.
Yeah? This was probably the more straightforward one, but they both work and end up getting the exact same matrix. Only the identity matrix. Second row, first column.
0, 1, 0.
0, 0, 0.
0, 4, 0.
And then you guys can tell that little guy totally blocked up something or others, but I am going to end up getting -1 to -3. So the identity matrix is that special one that says, oh hey, I'll keep it the same, and that's exactly why he's called the identity, because he is what we call the multiplicative identity. The additive has to be all zeros at the same order. The multiplicative, well, it actually has to be a square matrix, which is why I only have n, because it's only one dimension. Well, it's 2 dimensions, but they're the exact same thing because it's an n by n. The identity matrix always has to be square. Kiddos, what we didn't get to today was basically just some homework help as far as, oh, you didn't know how to do that, kind of. Oh, look, it's our Dairy Mart. Hi, little Dairy Mart. This one will probably be a homework help that you guys will bring to me to talk about when we come together next time. Remember, exciting posts coming this weekend to get ready for Pi Day on Monday. And last but not least, I'm not going to solve it, but I will go ahead and label stuff like we did earlier today. The example of skim 2% whole. Except they talk about business weekend, which would be Friday, Saturday, Sunday. And then they talk about for Friday, Saturday, Sunday.
Monday.
The selling prices. Monday's not the weekend, not usually. Profits. Bye guys.